Good evening, children.
Good evening, ma'am.
Good evening.
Good evening.
Good evening.
Good evening,
Good evening,
children.
ma'am.
Good evening. Yeah, I've shared my screen. Visible to all of you?
Yes, ma'am.
All right.
Yes, ma'am.
All right. So this is arithmetic progressions. All right. So the notes, the introduction notes I've shared on WhatsApp. What's the status like? Almost done? Still writing?
Yes, ma'am.
Okay. Maybe you can just check and, leave some amount of pages so that you can complete it later. So when we start today's classwork, leave some space equal to the amount of work you have to still complete, and then start writing today's classwork. Okay. So now let's understand what this term sequence means. So a sequence is a set of numbers arranged in a definite order following a definite rule. A set of numbers arranged in a definite order following a definite rule is called a sequence. Now let's use the rule n square minus 1, where n belongs to, say, natural numbers, and generate the sequence. We'll use the rule n square minus 1, where n belongs to natural numbers. You can say whole numbers, integers. Okay, so here we say n belongs to natural numbers. Now using this rule, let's generate the numbers in the sequence. So because n belongs to natural numbers, 1, 2, 3, 4, 5, and so on, is a collection of natural numbers. So in n square minus 1, when n is equal to 1, 1 square minus 1, 0. When n is 2, 2 square, 4, minus 1, 3. When n is 3, 3 square, minus 1, 9 minus 1, 8. When n is 4, 4 square, 16, minus 1, 15, and so on. So now 0, 3, 8, 5, these numbers are generated using this rule n square minus 1. So these numbers are said to be or form a sequence. Why a sequence? Because we have written a set of numbers in a specific order. See, you cannot change the order. You cannot write 3, 0, 15, 8. No. So here you see a set of numbers. It goes on. Okay, you see a set of numbers written in a specific order. And they all follow this rule n square minus 1. The order is also important. And the numbers in the sequence follow this rule. So that is what a sequence is about. A sequence is a collection or a set of numbers arranged in a definite order. The order is important, following a definite rule. Now, the terms of the sequence, they're separated by a comma. The terms of the sequence is separated by a comma. The nth term of a sequence is normally called an or tn. Nth term is any particular term, say the 100th term or the 1000th term. Nth term in the, see, now again, we have two types of sequences, finite and infinite. So finite sequences, when you know the last term of the sequence. Finite sequences when you know the last term of the sequence. So the sequence ends somewhere. You know the last term. When you don't know the last term, then the sequence is an infinite sequence. You don't know the last term. The sequence goes on forever. Okay, so that's an infinite sequence. So when we say nth term of a sequence, it represents any particular term of the sequence. It can be the term in the 10th place, the 20th place, the 30th place. So nth term need not be the last term, need not be the last term of the sequence, but it can also be the last. It can also be used to represent the last term. So nth term is a general term of the sequence. Nth term is a general term of the sequence represented by these symbols, Tn or An. So here you see this rule. We have taken a different example. So in the same way, here a sequence is generated. The rule is 2n plus 1. And n belongs to natural numbers. So putting n 1, 2, 3, 4, 5, we get a1. That is the first term, 3. Second term, 5. Third term, 7. Okay. Fourth term, 9. Fifth term, 11, and so on. So these are the numbers of the sequence, 3, 5, 7, 9, 11. These numbers form a sequence because they follow a definite rule. And we have arranged the numbers in a specific order. The terms are separated by a comma. Now this sequence is said to form an arithmetic progression. Now an arithmetic progression is a sequence. An arithmetic progression is a sequence. Now there are different types of progressions. So we have arithmetic progressions, geometric progressions, harmonic progressions. So in class 10, we'll be learning only about arithmetic progressions. So I said we also have geometric progressions, harmonic, geometric and harmonic progressions. So these progressions are nothing but sequences. So they follow a specific rule. If a specific criteria is met, then that sequence is an arithmetic progression or a geometric progression or a harmonic progression. For a sequence to be called an arithmetic progression, it should satisfy a specific criteria. For a sequence to be called a geometric progression, it should satisfy a different criteria. Similarly, for a sequence to be called a harmonic progression, it should satisfy, the numbers in the sequence must satisfy a particular criteria. Now we'll be learning the criteria to understand where a sequence can be called an arithmetic progression. So here in this example, these numbers are said to be an arithmetic progression. Why? Because the difference between any term and its preceding term is a constant. This is the rule. If in a sequence, the difference between any term and its preceding term, the term before it. In a sequence, if the difference between any term and its preceding term is a constant, is a fixed value, then that sequence is called an arithmetic progression. Now this fixed difference or that constant can be 0, it can be negative, it can be positive. It can be 0. The difference can be 0, the difference can be negative, it can be positive. So in a sequence, if in a sequence, the difference between any term and its preceding term is a fixed value, is a constant, is a fixed value, then that sequence is said to be in arithmetic progression. So here if you see, now 5. What is the preceding term? 3. What is 5 minus 3? 2. So this is the difference. Now let's check with the let's check with 7 and 5. That is 7 is a term and its preceding term is 5. So 7 minus 5, 2. Again, 9 minus 7, 2. 11 minus 9. Take any term and its preceding term. Find the difference between any term and its preceding term. So you see that the difference between any term and its preceding term is 2 everywhere. So it's a constant, meaning a fixed value. It's 2 everywhere. So this sequence is said to be in arithmetic progression. So the criteria to be satisfied, or the condition to be satisfied by the sequence, is that the difference between any term and its preceding term should be a fixed value, should be a constant. If this condition is satisfied, then the sequence is called an arithmetic progression. A sequence in which each term differs from its preceding term by a constant, a fixed value, is called an arithmetic progression, written as AP. This constant is called the common difference of the AP. The common difference can be negative, 0, or positive. An AP with finite terms, that is, if you can count, okay, finite, it starts somewhere, it ends somewhere. You know where, you definitely know where it starts. So you also know where it ends. You know the last term also. So then that is, the AP has finite terms, countable number of terms. See, it might have like 1 crore terms, but it's still countable, meaning you can find out it's 1 crore, right? So it might be a very large number, but still it's countable. It starts and ends somewhere. So an AP with finite terms is called a finite AP. An AP with infinite terms is called an infinite AP. So if you don't know, if you know the last term, it's a finite AP. If you don't know the last term, it goes on and on. Then it's an infinite AP. If you know the last term, first term, definitely we know. There will always be the first term because that's where it begins, right? The arithmetic progression. So the first term is always known. If you do not know the last, if you know the last term, finite. If you do not know the last term, infinite. So here show that the progression 8, 11, 14, 17, 20 is an arithmetic progression. You must show that this progression or the sequence. Okay. See, when we use this term progression, don't think there's only arithmetic progression. So don't mistake the question to be show that the arithmetic progression, this one is an arithmetic progression. No, no. Progression means a sequence. Show that the sequence is an arithmetic progression. Okay. Because we have different sequences, different arithmetic progressions, AP, GP, HP. So show that the progression, okay, so the sequence with these numbers is an arithmetic progression. Find its first term and the common difference. So these are the terms of the sequence. Let's check. 11 minus 8 is 3. 14 minus 11, 3. 17 minus 14, 3. 20 minus 17, 3. So 11 minus 8 is the same as 14 minus 11, is the same as 17 minus 14, is the same as 20 minus 17. It's 3. It's a constant. It's a fixed value. So what do you understand? Each term differs from its preceding term by 3. So the given progression is an arithmetic progression. What is its first term? The first term is 8. And what's the common difference? 3. The common difference is 3. That fixed value, that constant is the common difference, which is 3. I can see somebody here with no name, meeting guest. Please say hi and tell who this is. Yeah. Okay, let me just second. Somebody has not named yourself in the meeting, so you know it. Say hi, tell me who this is. See, that person has left the meeting now. Okay. All right. So far, good children? Any questions so far? Oh, it was
Yes,
Akshata, is
No.
it?
yes, ma'am.
Oh, sorry, darling. Okay, okay. No, no, no. Just wanted to, know who it was. Okay, okay. Thank you. Yeah, children. Back to my question. Any questions? Is it okay so far?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Very nice. Same thing here. Show that the progression 11, 6, 1, -4, -9 is an arithmetic progression. Find its first term and common difference. So 6 minus 11, -5, 1 minus 6, -5, -4, -1, -5, -9, -4. Should find the difference between a term and its preceding term. Should find the difference. So the term is -9. Its preceding term is -4. You must find the difference. So it's -9 minus -4. So it's -9 plus 4, which is -5. So the difference between any term and its preceding term is a fixed value, which is -5. So the given sequence or the given progression is an arithmetic progression. Because the difference between any term and its preceding term is a constant, is a fixed value, which is here -5. And the first term is 11. The common difference is -5. So here you have a sequence like this. You need to show that it's an arithmetic progression. So wherever possible, express the surds as a mixed surd. Wherever possible, express the surds as a mixed surd. As a mixed surd. Children, just a minute. I'll have to answer the doorbell. Just a minute. Yeah, thank you, children. So I was telling you, wherever possible, express the surd as a mixed surd. So 28, 2, 14 times 2 sevens are 7 ones are. So square root of 28 is equal to square root of 2 into 2 into 7. So from 2 twos, 1 2 out. From 2 twos, 1 2 out of the square root. So 2 root 7. So 2 root 7. So here I've expressed 28 as a product of a perfect square and another number. So 28 is, see, like 28 can be written as 2 into 14 also. But I choose to write it as 4 into 7 because 4 is a perfect square, right? If it's a perfect square, it's easy to bring that number out of the square root. So I've written 28 as 4 into 7, where 4 is a perfect square. 63 as 9 into 7, where 9 is a perfect square. So otherwise, you can easily do this one. 3, 21 times 3, 7s are 7 ones are. So square root of 63 is equal to square root of 3 into 3 into 7. So from 2 3s, 1 3 out. So 3 root 7. 3 root 7. Whichever way. All right. So root 7 is root 7. Root 28 is 2 root 7. Root 63 is 3 root 7 and so on. Now the difference between this term and its preceding term, 2 root 7 minus root 7. Oh, sorry. Okay. Okay. So 2 root 7 minus root 7. And the difference between 3 root 7 and 2 root 7 is the same, root 7. The difference between any term and its preceding term, the difference between these two terms, 2 root 7 minus root 7 and 3 root 7 minus 2 root 7. In both the cases, the difference is root 7. So the given progression is an AP with common difference root 7. And the question is also to find the next term. The next term. So what will be the next term? What will be the next term? So this is root 7. This is 2 root 7. This is 1 root 7. 1 root 7. This is 2 root 7, 3 root 7. So the next one is 4 root 7. So the next one is 4 root 7. But if you have to write it as a pure surd like this one is a pure surd. This one is a pure surd. Okay, when you write it like this, when you write this as this one is a mixed surd. Mixed surd. Pure surd is one in which the rational factor is 1. The rational factor. Root 63, no? So before that, the rational factor is 1. It's a pure surd. So when you write square root of 63 as 3 root 7, this one is a mixed surd. Okay, so 4 root 7 is the next term. That's a mixed surd. But in the question, the terms were pure surds, right? So if you have to write 4 root 7 as a pure surd, then it will be 4 when it comes under the square root, you will have 2 4s. 1 4 out of the square root. So inside the square root, 2 4s. And that's 7. So 4 4s are 16. 16 7s are 112. So square root of 112. Common difference is root 7. And the next term after 3 root 7 will be 4 root 7. This is a mixed surd. But in the question, the terms are pure surds. So this is how you write 4 root 7 as a pure surd. So when you take 4 under the square root, you'll have to write it 2 times. The square root of 112 is the next term. Similar question. So you can see I've written 18 as 9 into 2, 50 as 25 into 2. So you can see perfect square into 2, perfect square into 2, perfect square into 2. Not that you should do it like this. You can also do, okay, you can use this method and write square root of 18, square root of 50 and square root of 98 as mixed surds. You can write these 3 as mixed surds like this by finding out the prime factors also. So you know that. Okay. So when I write it as 9 into 2. So square root of 9 is 3. So 3 root 2. Square root of 25, 5. So 5 root 2. Square root of 49, 7 root 2. Now how to check if it's an arithmetic progression? 5 root 2 minus 3 root 2. 7 root 2 minus 5 root 2. In both the cases, the difference is 2 root 2. The difference is 2 root 2. So since the difference between any term and its preceding term is a constant, The given progression is an arithmetic progression. The common difference is 2 root 2. And the next term will be 3 root 2, 5 root 2, 7 root 2. So it has to be 9 root 2. 3 root 2, 5 root 2, 7 root 2. So then next one will be 9 root 2. 9 root 2. 9 root 2 meaning this is a mixed surd. To write it as a pure surd, it will be square root of 9 into 2, which is square root of 162. Okay. Okay. This is hiding the top line. I'll just read it for you. Okay, find A and B such that the numbers A, 9, B, 25 form an arithmetic progression. Okay, find A and B such that the numbers A, 9, B, and 25 form an arithmetic progression. So if the numbers have to form an arithmetic progression, the difference between any term and its preceding term will be a constant. If the numbers have to form an arithmetic progression, then the difference between any term and its preceding term must be a constant, will be the same. So that means 9 minus A will be the same as or should be the same as B minus 9 and should be the same as 25 minus B. If the terms have to form an arithmetic progression, then the difference between any term and its preceding term should be a constant. So 9 minus A should be the same as B minus 9, should be the same as 25 minus B. 9 minus A, B minus 9, 25 minus B. See, all should be equal. Okay. So now solve. If you take up this one first and solve, you cannot find because there are two unknowns A and B, right? There are two unknowns A and B. So you cannot find anything. So don't do that first. Don't do that first. Work B minus 9 is equal to 25 minus B. B minus 9 is equal to 25 minus B. Work this one first. So you get B is 17. And then work this. 9 minus A is equal to B minus 9. 9 minus A is equal to B minus 9. You know B is 17. So you can use that and you find A is 1. So A 1. So the value of A is 1 and the value of B is 17. Any questions, children?
No, ma'am.
No, ma'am. No, ma'am.
All right.
No,
So
ma'am.
class, very good. Class, use the emoji, raise your hand. Very good. Very good, children. Thank you. Yeah. Okay. All right. So here you see how to find, the any term of the AP. Okay, given an AP, given the first few terms of an AP. Okay, so you say you're given the first 3 terms of an AP, and you're asked to find the 1000th term or some 395th term. So it's not easy to, add, it's not easy to find the next terms and then go up to the 395th term. It's time consuming. So you need to have an expression or a formula to find any term of the AP. So normally in a sequence or in an arithmetic progression, the first few terms will be given. Minimum 3 terms will be given. 3 terms minimum will be given. So given those 3 terms, okay, given that the sequence forms an arithmetic progression with those 3 terms given to you, The question will be to find some particular term of the AP, which you cannot manually keep adding or subtracting and finding it out, right? Because it's time consuming. So you need to have a formula or an expression with the help of which you can find any term of that arithmetic progression. And that's what we're going to derive now. So we're going to derive the formula or the expression to find any term of the AP. So that any term of the AP, we say nth term of the AP or the general term of an AP. Any term of the AP meaning the nth term, 10th term, 20th term, 30th term, nth term, any term of the AP, which is also called the general term of an AP. Nth term is called the general term of an AP. Nth term of an AP is called the general term of an AP. And general term is any term of the AP. Okay. So this is not a proof or something. This is a derivation. Derivation meaning by observation, we understand that, this expression will help us find that nth term of the AP by observation. So let's understand what that is. So to find the general term of an AP, that's what we're going to do now. Let A be the first term of the AP and the common difference be D. The common difference is what? The difference between any term and its preceding term. That's the common difference. Common difference is always a term minus its preceding term. Like third term minus second term or 10th term minus 9th term. Not 9th term minus 10th term. No. 50th term minus 49th term. Second term minus first term. That is the common difference. Not first term minus second term. Okay. So let A be the first term of the AP and the common difference be D. Then we'll find the terms of the AP. Then the terms of the AP are. Okay. Follow me. Don't read, any other part of the slide. We'll go together. Then the terms of the AP are, what will be the terms? A1 is the first term, A2 is the second term, A3 is the third term, A4 is the fourth term, and AN is any term, like general term. So here it's like the last term. Here it's like the last term. Okay. So A1 is the first term, A2 second term, A3 third term, A4 fourth term, AN nth term. Okay. So now A1 is represented as A because let A be the first term, no? So A1 is nothing but A. Don't see the rest of, don't see all this. Don't see all this. Okay. So what is A1? A1 is A. The first term is A. Now how do you get the second term? The second term is the previous term. The previous term, that is, see, A2. The first term is A. The second term is the first term plus the common difference. Plus the common difference. Now see here. So what is the first term? What is the first term? It's A, no? A plus D. Now look at this. A plus D. This is the second term. This is the first term. What is the difference? D. See, D is the common difference. D is the common difference. A1 is the first term. So we're calling that A. A2 is the second term. How do we write the second term using A and D? Using A and D, how do you write the second term? The second term is the first term, that is A1 plus D. I'm telling you how. So now that A1 is nothing but A plus D. Now is this right? Yeah, it is right because the second term A plus D minus the first term A. What are you getting? Yeah, we are getting the common difference D. The common difference is D, no? And what is the common difference? It's the second term minus the first term. Yeah, second term minus first term, we are getting D. So we are right. Now what's the third term? The third term is the second term. What's the second term? A2 plus D. The third term is the second term plus the common difference. Now what's the second term? It's a plus d plus d. So it's a plus 2d. A plus 2d. Now, now let's check. Now what is this? What's the third term? A plus 2d. What's the second term? A plus d. Now we should, when you subtract, the common difference should be d. This is the third term. This is the second term. So a plus 2d minus a minus d. So a minus a cancels. 2d minus d is d. Yeah, correct. So the first term is a. The second term is the first term plus the common difference, which is nothing but a plus d. The third term is the second term plus the common difference. The second term is a plus d, a plus 2d. The fourth term is the third term plus the common difference. The third term is a plus 2d. The third term is a plus 2d plus d, which is a plus 3d. Now, so now what is this a1? It is a. What is a2? A2 is a plus d. What is a3? It's a plus 2d. And what is a4? It is a plus 3d. Now, you want to write everything in terms of a and d. Okay, now this a is only a, no? So you can write it as a plus, there's no d, so 0d. A plus 0d. A plus 0d. A is nothing but a plus 0d. You want every expression to have a and d in it. Okay, so this a, the first term a does not have d, right? So it is a plus 0d. Now the 0 can be written as a plus 1 minus 1 into d. 0 is 1 minus 1, no? 0 is 1 minus 1. So a plus 1 minus 1 into d. Similarly, the second term a plus d can be written as a plus, it's 1d, no? 1d. 1 is 2 minus 1 into d. And what is 2? A plus 2 is 3 minus 1 into d. And what's 3? A plus 4 minus 1 is 3, no? So you see that the first term a, the first term a or a1 is a plus 1 minus 1 into d. The second term a2 is a plus 2 minus 1 into d. The third term a3 is a plus 3 minus 1 into d. The fourth term a4 is a plus 4 minus 1 into d. So going by this rhythm, we understand that the nth term should be a plus n minus 1 into d. So this is the derivation. So if you want to find any term of the given arithmetic progression, you should use this expression or this formula. You can find any term of the arithmetic progression an using this formula a plus n minus 1 into d. Let's do this together. Yeah. So we start by saying that let a be the first term and d be the common difference. Okay. So now we are going to generate the first few terms of the AP. We are going to generate the first few terms of the AP. A1, A2, A3, A4. The first 4 terms of the AP. A1, A2, A3, A4. First term, we have called it A. Now A is nothing but A plus 0D because we want everything to have D also in it, A and D. A is nothing but A plus 0D. And 0 is nothing but 1 minus 1 into D. Second term is the first term, A1 plus D. The second term is the first term plus the common difference. So this is nothing but, what's the first term A1? It's A plus D. Now A plus D means A plus 1D. A plus 1D. So A plus 1, no, it can be written as 2 minus 1. What is 2 minus 1? 1, 1D. 2 minus 1 is 1, 1D. So the first term is A plus 1 minus 1 into D. The second term is A plus 2 minus 1 into D. Now the third term. What's the third term? The second term plus the common difference. But what's the second term? This one. This is the second term. This is the second term. A plus D. Plus D. Plus D. So it is A plus 2D. A3 is A plus 2D. Now this 2 can be written as A plus 2 can be written as 3 minus 1 into D. See this D. 2 is written as 3 minus 1 and this D here. So A1 is A plus 1 minus 1 into D. A2 is A plus 2 minus 1 into D. And A3 is A plus 3 minus 1 into D. Now A4. A4 is the previous term, A3 plus D. That's the first step. Now what is A3 here you have? See here. This is A3, A plus 2D. This is A3, A plus 2D. A3 is A plus 2D plus D, which is A plus 3D. Now this 3 can be written as A plus, 3 can be written as 4 minus 1 into D. Okay, 3 can be written as 4 minus 1. So 3D is 4 minus 1 into D. So when you read this, A1, A plus 1 minus 1 into D, A2, A plus 2 minus 1 into D, A3, A plus 3 minus 1 into D, A4, A plus 4 minus 1 into D. So AN is equal to A plus N minus 1 into D. So this is the formula to find the general term of an arithmetic progression. Please practice it. Very simple derivation. And I told you this also, like why we are adding D. Okay, see, so this is the fourth term, right? This is the fourth term. A4, let's find A4 minus A3. We should get D. When you find the difference between any term and its preceding term, you must get D as the answer. Okay, let's do that. So what is A4? A plus 3D. Minus, what's A3? A plus 2D. Work this. A plus 3D minus A minus 2D. So A minus A cancels. 3D minus 2D is D. Yeah. So common difference is D. So the first term is A. How do you get the second term? To the first term, add the common difference. Whatever is the common difference, add it. How do you get the third term? To the second term, add the common difference. How do you get the fourth term? To the third term, so the preceding term, add the common difference. Is that fine, children? The derivation?
Yes, ma'am.
Very good. So you should just write everything in this form. So by observation, we understand that the nth term is equal to A plus N minus 1. This is nothing but, like just putting, like going on like this. I couldn't type it like that, so I just put dashes. It's like it goes on like that. Like A5, A6, A7, A8, A9, going on like that. An is equal to A plus N minus 1 into D. You don't have to put dash like this. I should have mentioned that. Just put lines like this. So that's about the derivation of the formula to find the nth term of an arithmetic progression. Now the difference between the terms arithmetic progression and arithmetic series is, well, if it's an arithmetic progression, then the terms are separated by a comma. If it's an arithmetic series, then see, an arithmetic series is of an arithmetic progression. An arithmetic series is of an arithmetic progression. So if the terms are separated by a comma, arithmetic progression. If you remove the commas, and replace them by the plus sign, then it's an arithmetic series. So if you have the arithmetic progression 4, 4 plus 5, 9, 9 plus 5, 14, 14 plus 5, 19, 24, 29, and so on. Now this one is an arithmetic progression because the difference between any term and its preceding term is a constant. 9 minus 4, 5. 14, 14 minus 9, 5. 19 minus 14, 5. So it's an arithmetic progression. Now if you take away the comma everywhere and replace that with a plus sign, arithmetic series, okay? 4 plus 9 plus 14 plus 19 plus 24 plus 29 and so on. If the comma is replaced by the addition symbol, then it's called an arithmetic series. Yeah. So now in some questions, you'll have to assume 3, 4, or 5 numbers in arithmetic progression. Okay, so in some questions, you will have to find 3 numbers that are in arithmetic progression, or find 4 numbers, find 5 numbers that are in arithmetic progression. So in such cases, it's always convenient to assume the numbers like this. It's always convenient to assume the numbers like this. If you have to find 3 numbers that are in AP, then use this assumption. Let the 3 numbers be A minus D, A and A plus D. If you have to find 4 numbers in AP, then assume it like this. Let the 4 numbers in AP be A minus 3D, A minus D, A plus D, A plus 3D. If you have to find 5 numbers in AP, then assume the numbers as A minus 2D, A minus D, A plus D, A plus 2D. So see here, it's like A in the middle, before this A minus D, and after this A plus D. This is for 3 terms. For 5 terms, A minus D, no? So A minus 2D, and take one A plus 2D here. So this is for 5 terms. I'll show you again. A, before this A minus D, and after this A plus D. This will be the assumption for 3 terms in AP. Just take one on either sides. So A minus 2D here and A plus 2D here. So this is how you assume 5 numbers in AP. 5 numbers in AP. For 4 numbers, remember, it is A minus D, A plus D. Then on this side, A minus 3D, on this side, A plus 3D. So you find the difference, okay? Here you will see that the common difference is D. Here you will see that the difference is 2D. Here the difference will be D. When we take a situation and work, we can understand still better. If you have little doubt somewhere, it's okay. Just leave it for now. When we take a question and work it, it will be clear. Then you can ask me if you still have a question. So this is how we assume 3, 4, or 5 numbers in arithmetic progression. Okay. So next is, let's understand how to find the sum of the terms, the sum of all the terms in an arithmetic progression. So sum of all the terms you can find if it's a finite AP. If you know the last term of the AP, you can find the sum of all the terms of the AP. But even for an infinite AP, you can find the sum up to some terms, like find the sum of the first 50 terms, first 100 terms, first 200 terms, and so on. So you can find sum for both finite and infinite AP. So if it's infinite, you cannot find the sum of all the terms. You can find the sum of the first few terms of the AP. The first few terms, first 50 terms, first 70 terms, first 1000 terms. If it's an infinite AP. For a finite AP also, not that you should find the sum of all the terms only. Even if it's a finite AP, you can find the sum of the first few terms also. Find the sum of the first 20 terms, find the sum of the first 40 terms. Okay. So we'll see how to find the sum of the first n terms. First n terms meaning n can be any number. First 10 terms. First n is 10, n 20, n 30. First 10 terms, first 20 terms. Okay. So let A be the first term and D be the common difference. Okay. So now let's write the first n terms because we have to find the sum of the first n terms, right? So to find the sum of the first n terms, you should know the first n terms. If you have to find the sum of the first n terms, you need to know the first n terms. What are the first n terms? Only if you know the terms, you can find their sum. So you start like this. You should say, let A be the first term and D be the common difference. Generate the n terms. You want to find the sum of the first n terms, right? So first generate the terms. Then the first n terms of the AP are A plus D, A plus 2D. This we already understood. Okay, this we saw earlier. A plus D, A plus 2D, A plus 3D. First term is A. Second term is A plus D. The third term is A plus 2D. Fourth term is A plus 3D. First term is A. Second term, A plus D. Third term, A plus 2D. Fourth term, A plus 3D. Okay. And nth term, A plus n minus 1 into D. So we know the terms. Okay, we know the terms in general. So the terms are A plus D, A plus 2D, A plus n minus 1 into D. Now we need to understand how to write, how do we get or how do we understand the previous terms, n minus 2 into D, n minus 3 into D, A plus n minus 2 into D, A plus n minus 3 into D. Let's see that. So we know that the nth term is A plus n minus 1 into D. This is the nth term. Now, how do you find the preceding term? If you have to find the next term, you should add D. Next term, if you want to find, you should add D. That's what we do, no? To any term, if you add D, you will get the next term. To any term. To the first term, if you add D, you will get the second term. To the second term, if you add D, you will get the third term. To the third term, if you add D, you will get the fourth term. So to the nth term, if you add D, you will get the next term, the n plus 1th term. So if you subtract D, you will get the previous term. So if you subtract D, you will get the previous term. Right? You will get the previous term if you subtract D, you will get the previous term. If you add to any term, if you add D plus D, if you do, you will get the next term. Minus D, if you do, you will get the previous term. So let's do minus D to get the previous term. So A plus D is common, no? D is common. See here, D is common. So what will you get? N minus 1 minus 1 because this is minus 1. D is common. So N minus 1 minus 1 into D. So A plus N minus 2 into D. Now to this one, you subtract D, you will get the previous term. So again, what's common here? A plus D is common. So this is 1 here. N minus 2 minus 1. So A plus N minus 3 into D. So the nth term is A plus N minus 1 into D. Its previous term, that is the N minus 1th term. If nth term is the last term, then before that will be the N minus 1th term. And before that will be the N minus 2th term. And before that will be the N minus 3th term. Okay, so that's how we get. Nth term is A plus N minus 1 into D. Before that will be A plus N minus 2 into D. And before that will be A plus N minus 3 into D. And before that will be A plus N minus 4 into D. Okay, I'll just tell you again. The nth term is a plus n minus 1 into d. If you want to get the next term, you should add d. If you want to get the previous term, you'll have to subtract d. You'll have to subtract d. You'll have to subtract d. So we want the previous term. So we'll subtract d. We want the previous term, so we'll subtract d. So a plus, take out common. There should be only two terms, a term, d term. That's all. A and its coefficient, d and its coefficient. That's all. Two terms, a and d terms. That's all. So d is common, no? D is common. So write n minus 1. Okay. This minus 1. So a plus n minus 2 into d. This is the previous term. To this one, you subtract d. A plus d is common. D is common. So n minus 2 minus 1. So a plus n minus 3 into d. Okay. So the terms of the first n terms of the AP are a plus d, a plus 2d, a plus n minus 3 into d, a plus n minus 2 into d, a plus n minus 1 into d. Okay, so we have generated the first n terms of the AP. Now we have to find the sum of all these n terms. We'll have to find the sum of all these n terms. So that means what? We have to find. Okay, so let Sn, let this symbol represent the sum to the first n terms of the AP. Let this symbol Sn represent the sum of the first n terms of the AP. That is A1 plus A2 plus A3 plus AN. This is the sum of the first n terms. And this A1 is only A. This A2 is A plus D. This is A plus 2D. And this one is A plus n minus 1 into D. So this one is Sn. Sn is equal to A1 plus A2 plus A3 plus A4 plus A5, so on till AN. That is Sn. Okay. So Sn is equal to A, this is the first term, plus A plus D, second term, plus A plus 2D, third term. So on like this, adding all the terms of the AP till the nth term. These are the terms, no? Adding all the terms till the nth term. This is Sn. Now write the same thing in the reverse order. Write the same thing in the reverse order. So Sn will be equal to, write this one first. Write this one first. Then write this. Then write this. Then write this. Then write this. And then write this. So what I have done is I have taken 3 terms from the beginning and 3 terms from the end. You will find it different in different books. So here what I have done is I have taken the first 3 terms from the beginning and last 3 terms. First 3 terms and I said first 3 terms from the beginning, sorry. First 3 terms and last 3 terms I have taken. Okay, first 3 terms and last 3 terms. So when you add them, it is Sn. Write Sn once again by adding the terms in the reverse order. So writing this first, then this one, then this one, then this one, this one, this one. Connect the terms with a plus sign because you're finding the sum. Connect, don't put comma. Connect the terms with a plus sign because we are finding the sum. Okay, so this is the next thing. Now add. Now add what? I've called this equation 1. I've called this one equation 1. And I've called this one equation 2. Okay, add equation 1 and 2. So we get Sn plus Sn, 2Sn, like x plus x is 2x. Sn plus Sn, 2Sn. 2Sn is equal to. Now add, see here children, here I've taken 3 terms, no? And below that you can see 3 terms. Add the terms one below the other. So what is this one plus this one? What is A plus n minus 1 into D? A plus A is 2A. 2A plus n minus 1 into D. So this one, this first term plus this first term is 2a plus n minus 1 into d. Okay. Then add the second term here and the second term here. Okay. So a plus d plus a plus n minus 2 into d. Add these two. A plus a, 2a plus n minus 2 into d plus d, no? So take out d common. Take out d common. So you have n minus 2 plus 1 plus 1. So 2a plus n minus 1, because minus 2 plus 1 is minus 1 into d. 2a plus n minus 1 into d. See, again, same thing. Same thing. 2a plus n minus 1 into d. What we got earlier. Now add the third term here and the third term here. Okay. We'll add the third term, a plus 2d, and the third term here, a plus n minus 3 into d. So a plus a is 2a plus, I'll take common as it is, no? So here 2d, here n minus 3 into d. When you take d common, you'll get 2 here. This is 2 plus n minus 3. This 2 plus n minus 3. So 2a plus 2 minus 3 is minus 1. So n minus 1 into d. See? N minus 1 into d. 2a plus n minus 1 into d. Okay, then we'll add the term here and the term here. You should get the same thing. No, we just did that addition. We just did that. A plus n minus 3 into d and a plus 2d. We just did that. We already did. See this one also. Adding these two. Yeah, we did that here. A plus d and a plus n minus 2 into d. We just did that here. And then adding these two. Yeah, that's what we did here, no? So when you add, you will get 2a plus n minus 1 into d everywhere. So 1, 2, 3, 4, 5, 6. Okay. So 2a plus n minus 1 into d, 2a plus n minus 1 into d, 2a plus n minus 1 into d. Like that it goes on. 2a plus n minus 1 into d. Now, how many terms have we taken? We have taken n terms. How many terms have we taken? N terms. So this sum 2a plus n minus 1 into d, we get it n times. Because we have taken n terms, no? The first n terms. How many terms have we taken here? N terms, like 10 terms, 20 terms, 30 terms, n terms we have taken. So this sum will happen n times. Because we have taken n terms. So n times. So 2Sn, because Sn plus Sn, 2Sn children. Okay, so 2Sn is equal to, this sum is happening n times. N times 2a plus n minus 1 into d. And n times in mathematics, times means multiplication. So n into 2a plus n minus 1 into d. 2Sn is equal to n into 2a plus n minus 1 into d. So 2Sn is equal to n into 2a plus n minus 1 into d. So Sn will be that 2 will come for division here. N by 2 of 2a plus n minus 1 into d. So this is the formula. This is the formula to find the sum of the first n terms of an arithmetic progression. Sn is equal to n by 2 of 2a plus n minus 1 into d, where n is the number of terms whose sum we have to find. Remember, this formula will help you to find the sum of the first n terms of the AP. Like if you have to find the sum from the 50th term to the 100th term, we can find, but not using this formula straight away. We can find. So again, when we take up a question, we'll understand better. But now remember that you can use the formula to find the sum of the first n terms. So you can find first 20 terms, first 30 terms. But if you want to find the sum from the 20th term to the 45th term, then you cannot use this formula once and get the answer. No. So n is the number of terms. A is the first term and D is the common difference. So when you substitute these values, you will be able to find the sum of the first n term of the AP. N terms of the AP. Now, this formula can be interpreted in a different way. So this is the formula. Sn is equal to n by 2 of 2a plus n minus 1 into d is the formula. Now, you can interpret this formula like this. Write 2a as a plus a. Write this 2a as a plus a. Okay, a plus a, and then this n minus 1 into d as it is. So now, a plus a, right? Now, consider this one, a plus n minus 1 into d. What is a plus n minus 1 into d? an, general term of the AP. A plus n minus 1 into d is an. Here, see here. An is a plus n minus 1 into d. So, a plus n minus 1 into d is an. So, you have another formula. Sn is equal to n by 2 of a plus an. That is the first term plus the last term. A plus an. Sn is equal to n by 2 of the first term plus the nth term. Like if you're finding the sum of the first 50 terms. So S50 is equal to n by 2, 50 by 2 of the first term plus the 50th term. If you're finding S125. Okay, so SN, S125, that is, you're finding the sum of the first 125 terms. A1 plus A2 plus A3 plus A4, so on till A125. You're finding the sum of the first 125 terms. So that is S125. That is S125. So S125 is equal to n by 2, 125 by 2 of the first term A1 plus the last term. Last term means the 125th term. You're finding the sum till the 125th term, right? So the last term is the 125th term. You have to find S500, the sum of the first 500 terms. It will be 500 by 2 of, because n by 2, n is 500. 500 by 2 of the first term plus the last term, which is the 500th term. So it's also written as n by 2 of a plus L. A is the first term. L is the last term, meaning the last term of the sum. From the first term to the 500th term, you're finding the sum, right? So the last term is the 500th term. So L, A plus L. So you'll have to remember this. Sn is equal to n by 2 of 2a plus n minus 1 into d. You'll have to remember this. And also, these two are the same. Just that an can also be written as L. These two are the same. They're not different. They're the same. You can say an, or instead of an, you can also say L. So Sn is equal to n by 2 of 2a plus n minus 1 into d. Or Sn is equal to n by 2 of the first term plus the last term or the nth term. So this can also be written as Sn is equal to n by 2 of the first term plus the last term, like this. Am I clear, children?
Yes, ma'am. Yes, ma'am.
Okay. I'll just stop the recording and give you some instructions.